Hi guys, this is our unit in geometry on circles. This is the first video. We're going to cover 11.1 examples in this video. So in your packet, 11.1 is all about parts of a circle. Some of these you guys already know, but we're going to introduce some new pieces here. And so here's a nice diagram to go with it. A chord is a segment. So remember, a segment ends, it has endpoints. Its endpoints are on the circle. A secant is very similar, but it's a line, so it goes all the way through the circle, and it crosses twice. A tangent only touches the circle once, and it's a line, and then that point where a tangent touches the circle, we call that the point of tangency. Okay, so now we're going to use that to identify the different segments. So I'm going to write down the different segments here. QP is a segment, QR, segment, S to T, it's got arrows, so I'm going to go ahead and put lines over that. UV has lines over it, and then I'm also just going to include point U just for practice. All right, so what are each of these things? Okay, so QP, that's one we already know. It's going from the center to the outside, or to a point on the circle. That is a radius. Okay. QR, okay, so this is a segment and its endpoints are on the circle. It's touching the circle twice, but it's not aligned. So that is our first option right here. That is a chord. Okay, ST goes through the circle, but it does touch it twice. So if it's a line passing through the circle twice, it is a secant line. Okay, UV, so this is also a line, but it's only touching the circle at one place. So this is a tangent line. And then U is what we would call the point of tangency. Okay, now here we have a circle. This one's on a graph, but that's okay. We have two actually. Identify the point of tangency and write an equation for the tangent line. Okay, so we have this point and this line. So this point is touching this circle and the circle just at that one place. So that is my point of tangency. We're going to go ahead and give the coordinates there since I don't have a letter to name it. So it's at 2, -1, +2, -1. And our tangent line is this line. So remember, equations of lines we typically think about like this. Horizontal lines have 0 slope. And then my y-intercept is -1. Well, 0 times x is just 0. So I have 0 - 1, or just y equals -1. So horizontal lines typically look like that. Y equals whatever number it passes through on the y-axis. Okay, next we have some more vocab. I already pulled these from the book, you guys. I'm going to talk a little bit about it. Some more vocab. So central angle. We've actually dealt with this already when we were finding area of regular polygons, but it's a angle whose vertex is on the center of the circle. We're going to be introducing something called an arc. So an arc is part of the circle, okay? And it includes all those points between those 2 points that are the ends of the arc and everything in between. Arc measure, we can measure central angles in degrees. We've seen that also when we were finding area of regular polygons. And it's always going to be a fraction of 360 because within a circle, a whole circle is going to be 360. So anytime I'm looking at a central angle, it's going to be a portion of that 360. Semicircle, this is probably one you guys are familiar with. It's at just half of a circle. And so the end points of the arc lie on the diameter. So if my endpoints are the diameter of a circle, this is a semicircle. So the arc measure is always 180 degrees for a semicircle, half of 360. How we name an arc, you guys, is we use this little arc symbol, and we can use either 2 or 3 letters. I'm going to talk more about that. I'm going to use 3 here because on my picture, I go from A to C to B. And I use this little kind of rainbow little arc. Or I could do B, C, A. I do want the endpoints to be the outer letters, okay? Now there are times where I can use 2 letters, and this is when I can do that. When we have a minor arc. So minor is something that's an arc smaller than a semicircle. So less than 180 degrees, less than half the circle, we use 2 letters. So this has to be less than 180 degrees. And we could name it like this minor arc up here is BA or AB. If it's a major arc, it's something that's bigger than a semicircle, so greater than 180 degrees, and we use 3 letters. So this one is 2 letters, this one is 3 letters. Typically, semicircles are also 3 letters. Okay, so this one I would do like BCA or ACB. So this one, same. Okay, all right. We did that. Sorry, keep track of my notes here. Okay. Now we are going to do some examples here. Okay, so this was asking us to find each measure. So JKL. So I'm J, then to K, then to L. So they're talking about this arc right there. So they want that angle. Okay, so a couple things I know. I'm given 40 degrees is this little angle right here. And I'm given this one's 25. Okay, the other thing I know is we actually have some vertical angles here. So actually, this angle and this angle are the same because they're vertical angles. So this one's also 25 degrees. J to M is going through the middle of the circle. That's a diameter. So this whole thing together is 180 degrees because it's half the circle. So what I'm going to do is I'm going to say, I'm going to kind of write down my steps. The measure of arc KJ is 25 degrees, and I'm just going to write vertical angles so I remember how I got that. Okay, and then I'm going to do 180 minus 40 plus 25. And this comes from the semicircle. Okay, and this is going to be the measure of arc JKL. Okay, so the arc measure is the same as its central angle. Okay, so when I do that piece, 180 minus 40 plus 25, we got 115 degrees. Okay, so this whole thing from there to there is 115 degrees. So that's the arc measure. That's also the central angle. They are the same thing. Okay, so I'm actually going to write that too. The measure of angle JKL is also 115. These are always equal. Okay, all right, JLJN. L, then to J, then to N. So notice I didn't go L, N, J. J's in the middle, so I go there second. Okay, so we could find this one because we could do 115 minus 25. So 115 minus 25 gives us 90. So this guy right here is 90. Okay. Next, they want LJN. So this piece right here, you guys, I can get by doing 180 minus 25, because again, half the circle minus 25. So 180 minus 25 gives me 155. So then LJN is going to be 90 plus 25 plus 155, and that's it. Or I could have also done 360 minus these two, because all the way around is 360, and then subtract these two. So that one's actually probably a little quicker. So I'm going to do 360 minus 40 plus 25. Which is what, 295, I think there? All right. Okay, couple more examples. You'll notice I scribbled out number 2. You guys can do the same thing. We haven't learned that vocabulary word yet. We're going to learn that one in the next section. Okay, so this again, we just have parts of a circle we are identifying. The center of the circle is a point, A in this case. A radius. So a radius has to go from A to any point on the circle. So one is not drawn in here, but I could create one as long as I go from A to any point on the circle. So there's actually lots of options. I'm going to do this one. I'm going to do A to D, excuse me. And it is a segment, so no arrows. Diameter. There is one drawn here all the way across the circle through the center, EF. A chord. Okay, so remember a chord touches the circle twice, but it's a segment. A diameter is actually also a chord, but we'll pick a different one. G to I. Okay, secant is just like a chord, but it's a line. It's going to have arrows, so it's got to go through the circle twice. So C to B would be an example of secant. Tangent line, a line that touches our circle only one time. So it's mostly outside the circle, so H to D. And this one has arrows. Point of tangency, so where does the tangent line touch the circle? At point D. A minor arc, so we want to name an arc that's less than half the circle. I'm going to do, again, lots of options here, guys. I'm going to do this arc from C to B. It's obviously less than half the circle, and I'm going to use that little arc. If it's a minor arc, I just do 2 letters. Major arc, so something that's more than half the circle, and we're going to use 3 letters. So I'm going to do E, let's do this. Actually, I'm going to do this one. We got too many options here. Okay, let's do G, F, and then I want to go all the way around to half the circle, so I get this plus this half circle. So G, F, I can pick any of these letters, you guys, but I got to end with G. So I'm going to go G to E, and I can use either F, D, or I. It doesn't matter. I'm going to do D. Okay, semicircle, half the circle. So E to F. Okay, again, typically these ones are 3 letters, so I need E and F to be the endpoints, okay? And then I can pick any of the other points in between. So I'm going to do C. Okay, all right. Now we're going to draw some parts. Draw an example of a chord. So we know we have to have a circle, and a chord touches the circle twice. Okay, label it JK. So my endpoints are J and K. Draw an example of a secant line. So again, we got a circle. Secant is just like a chord, but it goes through the circle. We're going to label it M, N. Draw an example of a tangent line. So tangent line only touches the circle once. Okay, so there's our tangent line. We're going to call it ST. So I'm going to make S be that point and T be another point on here. Okay, so S would be my point of tangency. What is the difference between a secant line and a tangent line? Well, let's look at our pictures. Secant versus tangent. Secant touches the circle twice. Tangent only touches once. Secant intersects a circle twice. And a tangent intersects once. Okay, 7. What's the difference between a chord and a secant? So again, I can use my pictures to help. Chord, secant, very similar, but one is a segment, one is a line. So chord is a segment. Secant is a line. Sorry, that's hard to read. Segment. Okay, all right. Use the figure to identify the arc as minor, semicircle, or major. So if it only has 2 letters, it's either minor. Let's double check and make sure none of the 2-letter ones are half circle. I don't think they are. So we have minor. So I can actually do this without even looking at the picture, because I know all the 2-letter ones are automatically minor. Okay, G, C, D. So I start at G, then I go to C, then I go to D. So that's over half the circle, so that is a major arc. D, F, A. D, F, A, that is a semicircle because its endpoints are D and A that are on the diameter. A, C, D, this is another semicircle because D and A are on the diameter. C, G, E. C, then G, then E. That is over half the circle. That is a major arc. Okay, last part of this video, guys. 11.1. We have one theorem that we're going to learn that says that if a line is tangent to the circle and it touches the radius at its point of tangency, they are perpendicular to each other. So what that means is that forms a right angle. Okay? All right, so in this first example, determine whether KJ is tangent. So, okay, KJ is tangent. So this is a radius, L to J. So basically I'm asking, is this a right angle? So I'm going to put right angle with a question mark. We don't know that for sure at this point. That's what they're asking us to basically verify. If I can show that's a right angle, then yes, KJ is tangent. If it's not a right angle, it's not tangent. So how do I do that? Well, I can kind of see I have a triangle set up. So I'm going to check, this is 4.2. So this radius is also 4.2. So that whole length is 8.4. So 8.4 squared plus 8 squared. I'm checking, does that equal 11.6 squared? If it does, then that is a right angle. If it doesn't, it's not a right angle. So let's check. All right, so we got 8.4 squared plus 8 squared, which is 134.56. Okay, and I'm going to do 11.6 squared. They are the same. So that means, therefore, I'm going to say LJ, that radius, is perpendicular to JK. So JK, or KJ, is tangent to circle L. All right, last example. Early in its flight, the Apollo 11 orbited the Earth at an altitude of 120 miles. Okay, so we have Earth. Apollo 11 is orbiting the Earth at an altitude of 120 miles. What was the distance from the spacecraft to Earth's horizon rounded to the nearest mile? Okay, so if we think about altitude, that's like a distance above Earth. So that is 120. I'm making that kind of small because, relatively speaking, 120 miles is not far above Earth with like respect to those huge measurements in space. And then we're looking out at the horizon. So as we talk about horizon, that's like where I see it intersect the Earth, right? We kind of see the edge of the Earth or where Earth falls off. So basically that's a point of tangency, okay? And then they're telling me what was the distance from the spacecraft to Earth's horizon. So we're looking for that. What is the distance from the spacecraft? So I'll put an A there for Apollo 11. So we're looking, what is the distance from A to Earth's horizon, okay? All right, well, I'm also given the radius of Earth is about 4,000 miles. So I'm going to draw those in. They're about 4,000. Well, if this is a point of tangency and this is a radius, by our theorem up here, the tangent line is always perpendicular to the radius. So I can put in a right angle here, and I can solve for x using Pythagorean theorem. So I can do x squared plus 4,000 squared equals, my hypotenuse is 4,000 plus 120. Okay, and then I can solve that from there for x. Okay, so I'm going to go ahead and square those. So 4,000 squared is going to be a nice big number. Is 16 with 1, 2, 3, 4, 5, 6 zeros. Okay, and then we got 4,120 squared. Okay, 1697. 4400. All right, so now I'm going to subtract that 16 million. And we're left with x squared equals 974,400. And then our last step is now take square root. So square root of 900,000, excuse me, 74,400. Approximately, and they want nearest mile, so that is a whole number. So the nearest whole number is 987. 987 miles. All right, that's all for this video, guys. Thanks for watching.